Hello and welcome to another technical takedown the hard way. In today's video we're going to be talking about aerodynamics. Yeah, I said that word, aerodynamics. It's not a word that we seem to use every single day because it's not a word which we think, especially even overlanders, we don't generally think that it's important when it comes to overlanding. Of course, if you take a look at some of the vehicles that people tend to use to go overlanding, vehicles like the old Defender and also the Jeep Wranglers, the JKs and everything else like that. When those cars are designed, aerodynamics, it's clear that aerodynamics wasn't the first thing on these people's minds. And this is not good, especially when it comes to finding a long-term overland vehicle which has good aerodynamics. And that also has the properties of being a tough vehicle which lasts, that can take a beating. So what I have done, and if you've looked at if you watched the last video when I spoke about the vehicle choices that we are looking at, the vehicles that we are looking at, yeah, baby.
Please don't tell me you ate all the sour snacks that I bought.
What sour snacks?
The sour worms, snakes that I put where the coffee is.
I don't know where they are, baby. I didn't even know you bought any. Wow. Thank you anyway for ruining my video. She's obviously bought some snacks and I've never heard her talk like this before. She's bought some snacks, she's hid them away from me and she's lost them. How funny. Anyway, so what was I saying? So the cars that we are looking into are a compromise between the two. Okay, we're not going for the toughest of off-roaders because they tend not to be aerodynamically efficient. Okay, and we're not going for these soft roaders because I think I'm pretty confident that a soft roader could make it all the way down to South Africa, but in the same way, do we want to take that chance having components which have been designed for taking the kids to school, to perhaps go up the odd curb every now and again? No, I don't think so. So we needed a car that can do both of those things. Okay, and a car that as soft roaders, if you look at soft roaders, they are mass produced normally. And when they are mass produced, they're mass produced for everybody, right? And if they're produced for everybody, it's important, right, that these car manufacturers have to have these cars be as efficient as possible, right? Because there are lots of strict regulations, especially in the United States and in Europe. There's a lot of strict regulations of how much fuel a car can burn. So aerodynamics come into play much more when it comes to your soft roaders and your mall crawlers. Okay, so it's important that we look at that because long-term overlanding, if we have a car which has good aerodynamic design, then we are going to save on fuel. It's really that simple. That's the reason why I'm not looking at any of the 79 series Land Cruisers or Defenders. They just don't have the aerodynamic efficiency that we are looking at, especially because it's going to, whatever vehicle we get is going to be, it's going to be a daily as well. whilst we are here. So it's important that the car can do both things, you know, that it's tough, dependable. More specifically, I want to spend the last half of this video talking about the rooftop tent. The rooftop tent, I need to design in a way which it's going to have very good aerodynamic properties. Okay, so we want it to do all the things, you know, that a good, well-built rooftop tent could do. We want it to do those things. However, we also want the rooftop tent to perform very well aerodynamically. So we have to look at trying to find out how aerodynamics work. And this will help us to design the rooftop tent. So I was out running this morning and I saw this. So this is a rooftop storage unit. And I love this. This rooftop storage unit actually is almost perfect. Okay, so if you see it, I mean, it's sort of almost, actually, if you look at the back of it, it comes up a little bit towards the rear. This is not brilliant, okay? It's not the best thing because of the way aerodynamics work. So when you have a flow of air over a surface, that air needs to be smoothed down, right? And what we are looking for is laminar flow, right? You get laminar flow on surfaces which have air going over it. Laminar flow is definitely something we need to look at. And having more laminar flow over that surface is very important. So let's say our rooftop tent, sorry, before I move on, it's important to remember that with all surfaces, even wings of an aircraft, there is always a certain degree of turbulent air disambiguation when it comes to laminar flow. You're literally riding on a cushion of low pressurized air when you are in flight. And it's difficult to notice us as humans, you know, because you're traveling very fast, but there is quite a bit of air disambiguation. And this air disambiguation, when it comes to laminar flow, so it always happens towards the end, depending on the design of this rooftop tent, right? We can increase the laminar flow or decrease the laminar flow and increase air disambiguation. And clearly, the air disambiguation is going to cause drag. Drag is something we do not want, right? We don't want drag. So what we are looking to do is we're trying to look at a teardrop effect. That's the type of shape that I am looking for. Teardrop. We want it so the thickness of this rooftop tent in the profile of the shape, that the thickest part is just towards the rear, not actually at the front. So it's not an actual teardrop. It's actually a bit of a pear, and then it gets bigger and then gets smaller. If we do things that way, we can maximize the laminar flow and better the aerodynamic my gosh, I'm losing my mind here. The aerodynamic properties of the rooftop tent. So that is what we are looking for. There is lots of equations. I mean, I could go into the equations, but I'm trying to keep things simple because I don't know much about this. I just know that in general, that's the type of shape that we are looking for. And we are going to be doing quite a bit of copying in terms of design. That's the best thing to do. If you look at all the greatest inventions on this planet, they've all been copies, normally copies of nature. So stuff that already exists. So we are looking for designs of other rooftop tents. I've seen the James Baru tents. I like the way that they shape the top of the tent. But you got to remember what I said yesterday when I said I wanted to have a glass panel roof, which means we're going to have a certain amount of surface area on the top of this car, where on the top of this rooftop tent, where the glass is going to be completely flat. So, you know, we have to be careful with this one. We have to be careful with the actual shape. It's not going to be fully noticeable that it's going to be teardrop, but it will be. It will be. And that is the shape that we are going for. So I'm going to be drawing up some rough sketches, and we're going to take it from there. We're going to see if we can design the perfect rooftop tent. You got to remember also the solar panels. But the solar panels, yeah, we're going to see. We're going to see how we do the solar panels. But in general, that's what we are looking at. So guys, thank you for joining me again. And thank you for sitting through me talking about aerodynamic and properties and laminar flow. There you go. Until the next time, I'll see you in the next one. Thank you for joining us. Goodbye. Oh man, wow.